I'm going to talk about graphs of linear inequalities. I'll assume that you know how to graph linear equations. If you don't, I would invite you to watch the necessary videos. All right? So let's start with the following example. Suppose that we wanted to graph this inequality. All right, so this inequality corresponds to points that have y values greater than or equal to minus 2x plus 6. Now, would you agree that the inequality corresponds to points that have y equal to minus 2x plus 6, right? Because it's the inequality symbol is greater than or equal, not just greater than. So it definitely includes the line y equal to minus 2x plus 6. So let's start by graphing that line. So the line y equal to minus 2x plus 6 has an x-intercept of 6. Excuse me, a y-intercept of 6 and an x-intercept of 3. Okay, so give me a minute to draw that graph. Okay, so that the inequality at least includes the points on that blue line. Now, it also includes points that have a y value bigger than 2x minus 2x plus 6. So where on the xy coordinate plane do you think points have a y value bigger than minus 2x plus 6? Well, on the blue line, the y value is equal to minus 2x plus 6. Now, let's use this reasoning. Doesn't the y value correspond to the height above the x-axis? So if a y value was bigger than something, doesn't that mean that it has a bigger height? Okay, so can you see that that would mean that the points would be above the blue line? They have a bigger height than points on the blue line with the same x value. So all of that is to say that this inequality corresponds to all the points above the blue line and also including the blue line. So you can shade the region above the blue line like I'm doing right now. Okay? And so all the graphs of linear inequalities will involve shading some region of the xy coordinate plane. Okay? Now, let's do another example. What about y is less than minus x plus 2? So once again, give me a minute to make a picture, an xy coordinate plane. Okay, so the graph does not include points where y is equal to minus x plus 2. Do you see why? Because the inequality is less than, not less than or equals. All right? So when a graph does not include a line, typically it's denoted with a dashed line. So I will, I'll draw the line, a dashed line that corresponds to y equal to minus x plus 2. So give me a minute to do that now. All right, so again, the reason that I drew a dashed line is because dashed lines correspond to lines that are not included in the graph of a linear inequality. Okay? So for this inequality, the y values are less than points that have a y value equal to minus x plus 2. So remember that y corresponds to height above the x-axis. So if the inequality corresponds to points less than that, or points with y values less than the y values on the dashed line, then it's going to correspond to all the points below the dashed line. All right, so for the graph of this inequality, I will shade the region below. Okay? So let me repeat that if the graph includes a line, we make the line solid. If it does not include the line, we make the line dashed. Okay? Now I would like you to try to graph an inequality. Would you please try to graph the inequality y is less than or equal to minus 2? So pause the video if you like and try that now. Okay, so I'll go ahead and do it as well. So I will first graph the points that have y values equal to minus 2. And so that will be the line there that I just drew. And then I will ask myself, where are the points located that have y values less than minus 2? So that's going to include points below that horizontal line I just drew. So that is the graph of that linear inequality. All right? Now I would like you to try a slightly more difficult one. So would you now please try to graph 3y minus 2x is greater than 0. All right, so again, pause the video and try that now. Okay, I will go ahead and graph this one. So first, I'm going to graph 3y minus 2x equals 0, and that's going to have to be a dashed line because the inequality does not correspond to points on that line. And to graph that line, I'm going to put it in slope-intercept form. So y is equal to 2/3 x. And so we will have the following picture. Give me a minute to work on it. Okay, so the line is going to go through the origin, and when x is equal to 3, y is equal to 2. All right, so there is a dashed line that corresponds to y equal to 2/3 x. Now, the inequality corresponds to y values greater than 2/3 x. If you don't see that, you can rearrange terms in the original inequality. The original inequality is equivalent to 3y is greater than 2x. Divide both sides by 3, so y is greater than 2/3 x. Okay? So that means that the graph of this inequality is going to correspond to points above the dashed line. Okay? Now I'd like to discuss what it would mean if a point satisfied two inequalities at the same time. For example, what if we wanted to graph the points that satisfied this inequality, 2x plus y is greater than 3, as well as this inequality, x minus y is greater than 1. All right? So before I answer that question, let me graph each inequality on the same xy coordinate plane. Okay? And in order to do that, I will first find the line that'll correspond to the border. So for the first inequality, that'll be 2x plus y equal to 3. And I can write that in slope-intercept form. Y equals minus 2x plus 3. For the second inequality, the border corresponds to x minus y equals 1, or x equals y plus 1, or y equals x minus 1. All right, so now that I have the borders, let me graph both inequalities. So give me a minute to do that. So the first border corresponds to a line with a slope of 3, a y-intercept of 3 and a slope of minus 2. It corresponds to a dashed line. The border has to be a dashed line, so I'll make that dashed. All right, and the first inequality corresponds to y values bigger than minus 2x plus 3, so it corresponds to points above that dashed line. So let me go ahead and shade the points above that dashed line. All right, now let me graph the second inequality. So y this time is equal to x plus 1 on the border. That line has a slope of y-intercept of minus 1 and a slope of 1. And I'll make that a dashed line as well. Okay. Now, for this inequality, we want y values that are less than x plus 1. Rearrange the original inequality, and you'll see that it corresponds to y values less than x minus 1. So that means that I need to graph The graph includes points below the purple dashed line. Okay, so now that we've graphed both inequalities, let's ask ourselves what it would mean to satisfy both inequalities. Wouldn't that mean that I have to be in the blue region as well as the purple region? Can you see that there's overlap between the blue and purple regions? So where does that overlap occur? Can you see that it occurs in this region that I'm coloring brown? All right, so that is the graph that corresponds to both of those linear inequalities. You see how that works? So now you need to find the overlap between the graphs of inequalities. All right, would you please try to graph a similar pair of inequalities? Okay, would you please try to find the graph that corresponds to both of these inequalities? So pause the video and try to do that now, please. Okay, so I'll go ahead and work it out as well. So let me first find the linear equation that corresponds to the border and put it in slope-intercept form. So for the first inequality, I have 2x plus 3y equals 4. So 3y equals minus 2x plus 4. Y equals minus 2/3 x plus 4/3. And for the second inequality, I have x minus 4y equals 1. So x minus 1 equals 4y. I subtracted 1 and added 4y to both sides. So y is equal to 1/4 x minus 1/4. So I divided everything by 4. All right, so let me now draw the graph of each inequality. So give me a minute to make some progress on that. All right, so the border y equal to minus 2/3 x plus 4/3, that has a y-intercept of 4/3. And the x-intercept is 2. So I can draw the line through those points. And the original inequality corresponds to y values less than y values of points on that line. So I'm going to shade the region below that line. All right, and now let's work on the other border and other inequality. So the other inequality has a y-intercept of minus 1/4. It's going to be right where that purple dot is. And the x-intercept is equal to, let's see, the x-intercept is equal to 1. So that line is going to look like this purple line, and that'll be a solid line. We want a solid line. Okay, and we need y values bigger than 1/4 x minus 1/4. So you can determine that by rearranging the second inequality so that you isolate y on one side. So we want to highlight the points above the purple line. All right, now we ask ourselves what points are in the purple region and in the blue region. So that's going to be the points that I'll shade in brown right now. All right, hope that is clear.